Thank you for the introduction. Can you hear me? Does it work? Okay, good. So yes, my talk will be about an experimental work on how we can use contemporary deep learning models to describe early Japanese photograph. This is a joint work with le Musée National des Arts Asiatiques, the Guimet Museum in Paris, and Teclia, a French company specializing in processing and recognizing historical documents. So the goal of the project is to study a very large collection of photographs, Japanese photographs, that are conserved at the Guimet Museum. So it's composed of almost 300 albums of Japanese photographs, almost 20,000 photographs. And this is one of the largest collection in the world of such items. It gives a broad overview of the commercial photographic production in Japan during a period which goes from the Bakumatsu era to the Meiji era. And this is very important because this is the period when Japan moved from an isolation. It was living really in isolation, and it started opening to the world, to the Western world specifically. And those albums were produced at a large scale, and they were produced for the visitors, for foreign visitors, for Western visitors that came to Japan for the first time. And they are very interesting because they provide a vision of Japan at this very specific time of major changes. And also, it's interesting because they were produced for foreigners. So it's a dual view of Japan, and Japan from inside, but for outside people. And since this collection is very large, it provides a great variety of material, technique, style, subject matters, and so the diversity is quite important. So the goal of the project is to develop new tool based on deep learning to explore, analyze this collection. The idea would be to be able to recognize iconographical elements in the photographs, to be able to study the content of the photographs, but also to identify recurring photographs and similar composition, to study how those photographs were composed by the studios, because those photographs were taken by early photographers in Japan, but they were most of the time composed in studio, and also to detect potential patterns in the way the album were collected. So the patterns in the sequences, in the sequence of image. And in the end, to be able to give a large-scale statistical analysis on the photograph, on the content of the photograph. So to do that, we can rely on a couple of pre-trained models, and the situation in digital humanities has really changed compared to 5 years ago. 5 years ago, we would have started this project by training models from annotation, but now we can just start by testing models, already trained model, pre-trained model. And we have a large choice of different models for doing a different type of tasks. So we can test captioning models, we can test object detection models, and we can test semantic image search. And I will present two use cases, one for captioning and one for semantic search. So image captioning is very simple. You give an image to the model and you ask to the model to describe the image. You can give context. So let's say you prompt the model with this instruction, which is, this is an image of the 19th century Japanese photograph. Describe it, and then you have a description which is pretty accurate of the content of the image. Here, the model says that the image can present a group of people, possibly samurai, and so the model gives a pretty good description, but it's not really what you want if you want to have a description of a collection of photographs to be able to make statistics or search. So you can ask the model to be more, I would say, more synthetic about the description, and for example, to only give a list of objects if you're interested in objects, and do not make sentence. You could do the same, like give what kind of photo is it? Is it an outside, inside? Is it in studio? Is it a landscape? So you can give a list, and you can give an instruction to the model to have a list as a result. So now the problem is to know what to make an evaluation, a quantitative evaluation of those models, because if you test them, you can have a feeling of if they are good or not. But what you would really like to know is how do they compare to a manual annotation. So we have compared 3 models, 2 open source models, one which is called CLIP, another one which is CCLIP, which is an improvement of the first one. Those 2 models are open source, and we have tested also ChatGPT version 4.0. So we have tested this model on manual tagging. So the idea is to compare what the model can predict to what a person has provided as tags on the image. So the image were already tagged by an historian of Japanese photography. And this historian used almost 2,000 different tags to describe the photographs, based on the content, on some element of the Japanese culture, type of photographs, some of the location. So we wanted to focus only on the content of the images, so that the model can predict common names. So we removed from the tagging everything that was not a common name. So we have created a sample of 6 albums, 275 images, and we reduced the tag set to 1,000, considering only common names. The reason of that is that we wanted to be able to validate the prediction, and without being a specialist of the Japanese culture. So we are able to validate if this is a river, but we are not really able to validate if this is a koto or a shamisen that is presented on the image. So we test 3 models. We use the same prompt so that the model has really the same instructions. And we test a list of possible tags, either the reduced tags, so only the tags that are present in the 190, so the 190 tags that are present on the subset of the image, or the complete set of tags, complete possible set of tags. So the goal of the model in this case is to predict the correct tag from a list of tags. So the quantitative evaluation is like this. So what you see on this table is the different type of models. So you have CLIP, CGLIP, and ChatGPT. You have the 2 sets of tags, the reduced one, 200 tags, and the full one, 1,000 tags. And you have measures of the quality of the prediction. What you can look at is the last column, F1, which is a mixture of the precision and the recall, the 2 other columns. So the precision is a measure of is the model able to predict correctly a tag, when the model predicts a tag, is it correctly predicted? And the recall is a measure of is the model able to predict the tag that was present on the image. What you can see is that there is a large difference between ChatGPT and the 2 other models, because if you look just at the F1, you go from 13% of accuracy, or F1, to 50%. And that if you just focus on ChatGPT, you can see that there is a large reduction of the performance of the model if you increase the list of possible tags. So we wanted to go into more details about that and look at what were the tags, what were the type of tags that were predicted. So if we look at this image, it was manually tagged with the blue tags here: topaz, boat, natural landscape, Kozugawa, rapids, people, river. And the model, when we used ChatGPT, the model was only able to predict the green tags, but it also predicted the red tag, cherry tree. That is correct, because you can see something which might be a cherry tree here. But that was not labeled by the expert. So we wanted to validate the prediction to see if the tags that were predicted by ChatGPT were still correct, but maybe not labeled by maybe not chosen by the expert. And when we do that, so in this table, you have a new reference, which is full validated. So this is an experiment when we use the full set of tags, but we validate the prediction to know if when the model predicts something, it is correct or not. And what we see is that in this case, with the precision of the model is going a lot is really improved because it goes from 25% to 80%. So it means that when the model predicts a tag, usually 80% of the time it is correct. But sometimes the model, the tag that was predicted by the model was not chosen by the expert. So it's a bit a limit of evaluating the model in captioning with a close keyword list of keywords. So the second experiment was about semantic search. So in this case, we don't want the model to predict a list of tags, but we want to be able to query images with text. So we use a clip model to do that. So we encode all the image with the model, and we encode the same way the text, the query, with the clip model, and we are able to make a search with the text query by comparing embedding the representation of the text query to the representation of the image, and we display the best result. So how does it look like? So you have an interface like this where you can type a text like river, and the model is able to look at all the images that are close to the representation of the query, which is river. So with a simple word like this, it works. You can also ask for more complex description like tea ceremony. In this case, well, it should be an interior. You should have a group of people and have a tea instrument in the center. But you can also ask for more complex queries with, for example, the shamisen, which is a very popular musical instrument. And in this case, in most of the images, you have a shamisen present on the image. So the limits of the model is that sometimes you have results that are a bit surprising. So when you ask for fish, in this case, you have this result, and maybe we can explain the result because the images that are shown here look like the skin of a fish. This is for the blue result. And also, if you look at the image of the woman in kimono, the shape of the woman in kimono is also it looks like a fish. So the limit of this model is that they are based on the texture and on the form of the image to identify the object that they want to predict. But still, this is also interesting because you can ask a modern question to an historical set of images, and when you ask to this set of images representation of Olympic Games, obviously there is no representation of Olympic Games in this data set, but still you have things that are maybe close to Olympic Games, like a wrestler here, or maybe people running with a rickshaw. Okay, in conclusion, so it's not very surprising, but we know now that models, contemporary models, are able to describe all photographs with common vocabulary in English and French. One problem is that if we want to develop an interface for Japanese researcher, we also need to have a search in Japanese, and currently it doesn't work. So most of the models are based on English or French or Western description. What we should also improve is the interaction with the thesaurus, which is the list of tags that we want to use. Maybe we could use a hierarchical approach to be more precise on description. And what we have found also is that the automatic evaluation is complex due to the subjectivity of the description, meaning that sometimes the manual description will not mention a tag because the annotator was not focused on this specific aspect of the photograph, but still it is a valid description. So for the next steps, we have now to move from a lab evaluation to a field evaluation. And just to finish, I would Just like to mention the tools that we have used for this study that are open source tools for document processing that we are developing at Teclia, ArcIndex, which is a document processing platform, Calico document processing annotation platform, and all the models that we develop are also published on Hugging Face. Thank you.